Hello, we are Apollo 20, a member taking part in this app development challenge. What you're about to see is our video, which will go over our code, program, errors we have faced, how we worked with mentors, our outreach, and some skills we acquired through this. What this video should help you do is understand who we are as a team and our program. So sit back, relax, and enjoy this short little video to learn about us, Apollo 20.
Let's get into our app. So basically this is just our home screen with our logo, and you get to the simulation by going through here in the nav bar. And by clicking this, it'll start loading our stuff.
The points that were provided in the spreadsheet allowed us to plot the mission path and the resultant velocity vector of the rocket. We also show the mission in real time by utilizing part of the data. Here you can see the Earth rotating on its axis, as well as the moon revolving around the Earth that matches up with the Artemis II mission. We used color in our user-oriented drop-down menu, which displays the current part of the mission, as well as having the rocket path change to that respective color upon enabling the nominal path. We also have a key for the resultant velocity vector. There is also a key for the number of antennas that are currently available. Here you can see our antenna rationale, which puts the prioritization list in order, moving the most prioritized antenna to the top of the list. This also includes information for the antenna, such as the diameter and slant range. As for the unit interface, we provide the ability to turn on the nominal path, which shows the colored rocket path, the path for the bonus file, as well as toggling the off nominal path. Not only that, but the drop-down menu allows the user to see the number of available antennas. Some examples of the core practices of the K-12 computer science framework coming into play were: we fostered an inclusive computing culture by creating numerous functions which improves accessibility and simplicity. We also recognized and defined computational problems by breaking the task into smaller tasks divided by the strengths of each group member. Not only that, but we developed and used abstractions such as 3D models that helped visualize the Earth, Moon, and rocket better.
The code, I used Orsina and other libraries, along with reading from a link budget function. I made mission path and link budget arrays for accessing data and read from both the data and bonus file to put data into those arrays. I used some variables and functions that reflected given formulas by NASA for antenna coordinates, resultant velocity vector, and distance calculations. I created our entities used in the simulation like Earth, Moon, rockets, and antennas. I used variables for the mission path such as time and distance that would be updated in the update function. I made the drop-down menu and changed color and text color for it over here. I also had functions and variables for changing path colors and showing visibility of paths, along with their respective buttons over here. Updating text in the drop-down menu over here and paths in real time, like the antenna prioritization over here, list order, which I did. And finally, I update the trajectory of the rocket all the way at the bottom and ensure that it looks forward on the path, and then along with path enabling, Earth rotation, and then a moving arrow.
To develop this program, we ran into a couple of errors. One error we ran into was the rocket spazzing out. The rocket would move all over the place and it wouldn't stay still on the flight path that it was directed on. To do this, NASA gave us some new data and we utilized that, which made the rocket more precise and stopped it from spazzing out. Another issue we ran into was our program crashing due to the amount of entities we were creating. As we were trying to map the mission flight path, we kept making entities for each point, leading up to 6,000+ entities, meaning our program would run really slowly and eventually crash. To fix this, we swapped to a single entity and used a line mesh to mark the flight path. One final issue we ran into was our program almost being deleted. We had some backup saved, so we fixed that.
We acquired many soft skills during our project. One of the soft skills we acquired was proper time management. Because we were able to complete all our assignments on time, we were able to start the next assignment and we were able to finish that also on time, meaning we were able to do extra stuff later. The reason for this was because we had good planning. Because we planned out everything we were going to do ahead of schedule, it meant that we knew who was doing what and no one got confused. Another soft skill we acquired was teamwork. We were all able to efficiently work as a team and fix each other's mistakes, while also settling between our differences on what we wanted in our project. A reason for this was because we had proper work ethic. Because we were respectful, kind, and caring to each other, we were able to properly work together and finish the assignment on time.
For this app development challenge, which the mentor Blaine led on a NASA Zoom call on October 24th to focus on groups and larger projects, as well as going on other Zoom calls to help out with our work on the link budget formula and coding the app, and the knowledge we learned from that helped us complete both tasks and get this project done on the deadline.
Moving on to outreach, you can access the website we made through this info tab in the app and by clicking this.
So along with creating the program, we also had to manage outreach as a core part of the rubric. So our two events were hosting the website and also handing out this flyer as you see right here. Now this flyer was created with the goal of helping people learn about the Artemis 2 mission and the NASA ADC. It has links to our website and YouTube which kind of help explain these things. So this was handed out during the lunch block when students are grouped together and we can target a large array of students who might not be members, the updates on our program and our socials. Overall, these events are done to help people learn about the ADC, help reach these outreach events that we are required to, and to overall spread information. Now, we were unable to do quantum day events due to the lack of their presence around our location, so we could not meet those. However, we could meet these two other events, and so we did. Well, there you have it. This was our video. You should have a better understanding of our program, our code, our outreach, errors, skills, and how we worked with your mentors in order to form this cohesive program that we submit to you today.